I'm Anil Kumar, and in these set of videos, we'll try to understand exceptions to the rules of rational functions. While studying rational functions, sometimes we formulate kind of rules in our mind which are not really true. And in these set of videos, we will try to understand them. And I hope that will help you to avoid many mistakes. The first one here is rational functions have restrictions in domain. Now, generally, we say rational function r of x is a ratio of polynomials. Let us say p of x over q of x, where q of x is not equal to 0. And that is, it leads to restrictions. So these restrictions are restrictions on domain, correct? These restrictions are restrictions on domain. Example, if we have f of x equals to 2 over x minus 3, then we know x is not equal to 3, since it will make the denominator 0, right? And so the domain is restricted. Domain is all real numbers except 3. If you have a function which is kind of x plus 1 over x square minus 4, then in this case x should not be equal to plus and minus 2, since both these values will give you a restriction. Well, generally, most of the functions will have, rational functions have restrictions like this. But there are many exceptions to this rule. How about this function? F of x equals to 1 over x squared plus 1. It is never 0 in the denominator. X squared plus 1 is always positive, right? So that is an exception to the rule. Now also, when you have graph of a function and you're trying to sketch their reciprocal, right? So if I have a function which is kind of like this, then the reciprocal of this graph will not be having any restriction. For example, how about r of x equals to 1 over g of x? Now in this case, we do not have any x-intercepts. Do you see that? So there are no vertical asymptotes. So in the above cases, what we see is, what is domain? In the above cases, domain is x belongs to real numbers, correct? There is no restriction in such cases. So that is an exception to the rule which I want to highlight in this video. I hope you get an idea. Okay? And that helps. Thank you and all the best.